Today we are going to learn about Rolle's theorem in calculus, in differentiation. So what does Rolle's theorem say? The Rolle's theorem says if the function fx, that means if this is a function fx, if this function is continuous on the interval ac, there is a point a and there is a point c, and this is a closed interval between this closed including points a and c. If this function is continuous, what do you mean by continuous? Continuous means if at every point the limit from the left hand side and the right hand side is the same. So the first condition is continuity. The second condition is that this function should be differentiable on the interval AC. That means not including A and not including C, but between A, just before C and just after A, but not including A and not including C. So between this interval, if this function is differentiable, number 2 condition, and number 3, the value of the function at the point A and C, fa is equal to fc. That means the value of the function at A is fa, the value of the function at the point C is fc. If this is the same, that means if fa is equal to fc, then there is at least one number. That means there is one number b. There is one value of x between A and C, but not including A and C. There must be a value b such that the differentiation or the derivative of that function at this point is equal to 0. Okay, so this is what Rolle's theorem says. So let's see this example on Rolle's theorem. Determine whether the function fx equal to 3x minus x cubed satisfies Rolle's theorem on the interval -1, 2. If it does, find the value of b that can be determined. So this is the function fx. These are the points -1 and 2. And we have to first of all see whether the conditions of Rolle's theorem are satisfied or not. So number 1 condition is continuous. Yes, it is continuous as it is 3x minus x cubed. It's a polynomial expression on this interval. Is it differentiable? Let's see. So f dash x is equal to 3 minus 3x squared. Okay, 3 minus 3x squared, right? So we see that this function is also differentiable on this interval -1 and 2. So let's see now the third condition. That means third condition is fa should be equal to fc. So what is fx equal to? Fx is equal to 3x minus x cubed. So f of -1, and we have to find f of 2. So this is 3 into -1 minus -1 whole cubed, and this is 3 into 2 minus 2 whole cube. So this is -3, this is and plus 1, which is equal to -2, and this is equal to 6 minus 8, which is -2. So we see that the third condition, fa equal to fc of Rolle's theorem, is satisfied. So Rolle's theorem is satisfied. Since it is satisfied, so there must be a point b between this and this point where the value of f dash b should be equal to 0. That is what Rolle's theorem is. So what is the value of f dash b? F dash b we have found out. F dash x is this. So if you plug in the value of b here, it will be 3 minus 3b squared, which should be equal to 0. So we have 3b squared is equal to 3b squared equal to 1. So b is equal to square root of 1, which is plus minus 1. Since -1 is one of these points on this one, so we cannot take the value of, so b can be equal to 1 or b can be equal to -1. But we cannot take the value of -1 as -1 is already one of the points in this, one of the interval points. Okay, and Rolle's theorem says that there should be a point between not including -1 and 2. So since -1 is one of the solutions, this cannot be a solution. So the b equal to 1 is acceptable. Okay, so this is how you solve problems on Rolle's theorem. That is all for today's lecture. Thanks for watching.